Hi, as part of my ongoing hoverboard balance chair project, I've been needing to get three MCUs talking to each other. I started off with simple serial RxTX, but as I span up the hoverboard motors, the RxTX lines obviously became too noisy and the communications between the devices broke down. So here I am looking at CAN buses. So let's say we're starting with an Arduino Uno. Because this board doesn't have an internal CAN controller, we're going to be looking for a CAN module that's got both a controller and a transceiver on it. So there's two options here. You can either go for a serial CAN module or an SPI CAN module. The serial CAN module's got an additional MCU on it, the Mega 168PA for example, and the Arduino talks over RxTX pair to the CAN module. So this is probably the slowest option and the latencies will be worse, but it'll be fine for basic usage. Then the other option that both Arduino Uno and Nano can use is going for an SPI CAN module. So here we've got a bunch more pins required, but it is going to be faster and the latency would be better. So I'd prefer to use this approach if I was using an Arduino Uno or Nano. So other devices such as the ESP32 have a CAN controller on board. There'll be dedicated pins like CRX and CTX that are designed to talk to the CAN transceiver. So with this approach, we're kind of talking direct CAN API sort of stuff, whereas with the other two there's a sort of weird layer in between where if you read the CAN specs you wouldn't necessarily immediately know how to set filters and headers and all that sort of stuff with this, but you know, if you've got like a dedicated CAN controller it'll make a lot more sense. Similarly, like there are devices such as Blue and Black Pill have CAN controllers. I've noticed with like Blue and Black Pill, people tend to use the TJA 1050 transceiver module, but with the ESP32 people tend to use the SN65 HVD 230. I'm not sure why that is, but it might be worth sticking with those pairings. And finally, I'm using this Discovery kit, which is basically can power brushless DC motors, and that's got a CAN FD controller on it. So CAN FD stands for flexible data rate, and there's a couple of cool things it does. It can basically send more data down the line, and it can work in a sort of backwards compatible mode with CAN2 devices. The other cool thing about this Discovery kit is that it comes with the onboard terminating 120 ohm resistor, which you can sort of flip on and off. Now, one of the kind of annoying things with all of these different sort of options is that each option requires a different sort of Arduino library to work with it. So the G431, you're going to be having to talk directly with the HAL libraries that are provided with STM32. Whereas the Blue Black Pill, you might want to use the ExoCAN library. ESP, you might want to use Sandeep Mysteries library, and so on and so forth. So we can split the devices into three groups. I'd probably marginally recommend devices that support CAN 2.0 over CAN FD, and this is mostly because there aren't that many tutorials for CAN FD, particularly in the Arduino space. So we're going to be moving on to some quick code samples. So back to my hoverboard balanced chair. So I've got three MCUs. I've got two Discovery kits that are CAN FD and one master which is an ESP32. So let's take a look at some code. So in this demo and code section we've got three devices connected to the CAN bus. The CAN bus has basically got a ground along the top there and then a CAN low and a CAN high through the middle. We've got three devices, the ESP32 which has got an onboard CAN 2 controller, and then these drone kits which have got the CAN FD controllers on them. There's one over here and one over there. So looking at the code, we've got two projects. Both of these are linked in the description below. The ESP32 has got a dependency on this Sandeep Mystery library, and the STM32, the CAN FD one, I borrowed the code here, and that's come from a chap called Arduino74. Thank you. He's over at simplefoc.com. But broadly speaking, the code on both is quite similar. So if we look at the drone kit code here, in the setup, I'm attaching an interrupt on the button. Every time you press the button, it will send a CAN message to the other devices, and then we call init CAN. Init CAN, basically we're calling init with a speed of 1 megabit. I could set up a filter here if I only wanted to receive certain CAN messages, but as I want to receive them all, I've just commented that for now. And this is where we specify the callback handler that we want to be invoked when the CAN message arrives. And looking at the callback, we're being passed a header and the data. I'm simply printing out the header's ID and how long, how many bytes of data there are, and the actual values for the data, and also toggling the LED. So here's my USB oscilloscope. It's showing the last CAN message, so I'll just press play now on that. So when I press the button on this drone kit over here on the left, you'll see two things happen. Basically, some LEDs will toggle here. There'll be a blue LED here will go on, and the red LED over here will go off, and hopefully also will capture a CAN bus message. Right, so the blue went on and the red went off, but the CAN message didn't get captured. That's my USB oscilloscope doesn't always capture messages. So looking at this message, we've probably got some start bits here, 11 bits of identifier. I think there's about 5 bits of control characters. Then there'll be the 16 bits, 2 bytes of data. Then I think it's like 15 bits of CRC, and then possibly an acknowledgement at the end. Well, that's it for me. I'm hoping that my hoverboard balance chair is going to work a bit better now that I've swapped out serial for CAN bus.